Hello everyone. First of all, I would like to thank the organizers and all the participants. So let me introduce myself. I am Sura Bolaris. I am a PhD student at National School of Computer Science Tunisia with co-direction from UCB Lyon. My research study interests social IoT theme variable and insertion composition. For the theme, we introduce our paper entitled Insertion Configurable IoT Composition with QoT Properties, with co-direction from Dr. Salma Sissi from FEMSG Tunisia, Professor Jamal Musliman from UCBL France, and Professor Sami Fayez from ISAM Tunisia. The subject can be looked at under the following headings: first, introduction; second, motivation scenario; third, background; fourth, state of the art; fifth, proposition; and finally, conclusion and perspectives. At this level, we present the abstract. Concerns about quality of service have arisen in the Internet of Things environment due to the presence of a large number of heterogeneous devices that may be resource-constrained or dynamic. At different layers of the IoT architecture, quality approaches have been proposed that take a variety of QoS factors into account. Things are not implemented with QoS or exposed as services in the IoT context. Uncertainty emerges as a consequence of the plethora of things as well as the variety of the composition paths. So we establish standard methods for the aggregation of things with uncertainty awareness while taking QoT parameters into account. With respect to introducing the context of our work, which is the Internet of Things, that is a network of physical and logical components that are connected together for the purpose of exchanging information and serving the need of an IoT service. In an open, dynamic, and heterogeneous environment like the IoT, coming up with the right cost of a product or service is always challenging. The availability of possible products and services, the characteristics of potential customers, and legislative act are just a few of the many factors that affect pricing. IoT is another ICT discipline that would benefit greatly from the ability to differentiate similar things. That cost was presented in the context of web and IoT composition by QoS that measure the kind of service provided by the system, such as availability, usability, accuracy, energy, time, throughput, interoperability, security, reliability, stability, and capacity. However, things are not implemented with QoS or exposed as services in the context of IoT. So let's consider the challenges in IoT, especially that the quality of service constraint is not suitable for the IoT context, and we couldn't represent quality thanks to QoS. So the thing is represented and associated with their behavior and duties that are having a set of non-functional properties. Especially, we will represent the resource constraints thanks to the energy quality. In addition, in the IoT context, the composition process is variable to the dynamic changes related to the heterogeneity of IoT device and the scalability challenge that we will present thanks to the uncertainty management and the imprecision management also. Here we present our illustrative scenario concerning the general IoT configurable composition, where several composition plans could be selected to establish an IoT service composed from multiple composite services. Here we present the Think service, which has two execution paths with probabilities P1 and P2 respectively. Let's mention that there is one TS in each execution path. So let's consider the response time and energy as QoT process and uncertainty S, each of which having different values of each possible TS. Uh, it's good to mention that the user requirements on QoT of the composite thing are: the response time should be less than 50 and the energy should be no more than 40 degrees, In fact, when the energy is more than 40 degrees, we record it the rate 20, and the rate else the rate is 10. The, this table depicts that there are four possible aggregation, and for that we used the proposed aggregation uh, formula proposed in the literature for time and for energy, and the results are as follows. We have here four composition possibilities. So the above analysis shows that single values are not enough to represent the QT of a composite TS, and the lack of information about probabilities of each execution path prevents the effective selection of composite TS's component. There are ups and downs in the QT of a composite service to execute different paths. Adding QT constraints on every execution path without considering the probability makes the user specified requirements too difficult to be satisfied. So, in addition to that, the theme composition should be built up by basic composition patterns, including parallel and conditional. As uncertainty generalizes in completeness and precision of the composition process, it's related to which path of composition could be executed regarding the QT of the same thing duty. As a result, we define the following challenges: modeling method for the IoT composition configurable and classic patterns, modeling method for the QoT of a component IoT, and an estimation of QoT method for thin composition patterns. Regarding the fact that the IoT composition faces two main challenges, such as the configuration or variability and the uncertainty. Hence, the variability is handled through the configurable composition language Atlas Plus, which represents the configurable composition plan reference model or CCRM, which is a graph oriented with two essential components, nodes and links. The nodes can be the Atlas language or according to the Atlas Plus language, the primitives, which are thing services, thing relationship, recipes, operators, and connectors that could be configurable or classic. On the other hand, according to the classic composition, several patterns have been presented using the QoS parameters and based on the notion of workflow, they have proposed the sequence and or XOR parameters, and in the context of the business process, they have proposed these operators or workflow patterns in the classic and configurable mode. So considering the most suitable model to represent quality in the context of IoT, let's consider the QoT model that have been proposed by Mohammed et al. That define the non-functional properties of a thing related to its duties. This model would revolve around three duties: sensing, actuating, and communicating. So as a result, a thing senses the surrounding environment in order to generate some outcomes. A thing activates outcomes based on the result from sensing, and a thing communicates with environment based on the results of sensing and activating. In this section, we will present the state of the art and the main approaches that motivated our work. Let's start the work of Jaeger et al. They presented an approach or a mechanism that introduced and determined the QoS of web service composition by aggregating the QoS dimensions of the individual services. The aggregation performance builds upon abstract composition pattern. Second, the work of Mamre et al. In that work, they proposed the QoT define the non-functional properties of a thing related to its duties. This model would revolve around three duties: sensing, actuating, and communicating. And finally, our work. We have previously published a configurable composition language named Atlas Plus that supports the configurable social thing composition. The proposed approach presents a CRM which is composed of primitives, operators, and connectors that are configurable or classic. As a result, we proposed an approach for handling uncertain composition with QT parameters. In this section, we depict the main architecture of our approach, which is named QT UCC, and is composed of three models. The first model consists of the QT definition in each thing. Next, the composition model, which is based on Atlas plus theorem with probability annotation. And finally, the uncertainty of the final composition is computed through the patterns formulas such as OR, XOR, and sequence formula or operator. In this section, we will represent the main composition pattern. In fact, workflow control patterns in real-life business process scenario have been identified in several approaches, especially in IoT context. We defined a theorem that handles only the four composition patterns such as sequence and OR and XOR. In our approach, the loop pattern is not handled. These basic patterns include are the same as sequential pattern, parallel pattern, conditional pattern in the composition process. So let's start with the configurable sequence, which consists of a set of primitives executed in sequence. A sequence may contain configurable and non-configurable primitives. The sequence could be active or blocked. For the XOR, it can be configured in sequence or in conventional XOR. This connector consists of two or more branches, and among these multiple branches, where one and only one will be executed. For the configurable OR, it consists of sequence with n possibilities and three possible connectors, OR, and XOR. For the configurable AND, it could be configured to AND. The AND connector consists of two or more parallel branches in the case of a relationship or service block. Here we depict the possible customization of these configurable patterns. Let's move to the main step of our proposition, which is the quality of thing probability aggregation formulas based on the different patterns. Based on the quality of service principle, the quality of thing metrics are classified into 5 categories according to their characteristics in different composition patterns, which are as follows: additive, multiplicative, concave, convex, and weighted additives. So, in each configurable composition, we define the appropriate formula. In the case of C sequential pattern or configurable sequence, let's be the probability of the incoming paths be px equal to pi, where p is between 0 and 1, and I is in 1 and n. The QT of the energy consumption values are the possible Vex and Vey for the general Ex, as well as the quality of thing of the execution time are the possible Vtx and Vty for the general Tx. The sequential are computed according to formula 3 and 4. In the case of C AND or configurable AND pattern, for AND, let Bpx is the probability of the incoming paths. The quality of thing of each energy and time values is Ex and Tx respectively, and the computation of the energy and time is presented according to formula 5 and 6. In the case of C XOR pattern, let Px the probability value for the incoming paths, and Ex and Tx the energy and time quality of thing values respectively. The computation of uncertainty will be presented by formula 7 and 8. In the case of C OR pattern, the probability value for the incoming paths and Ex and Tx the energy and time of quality of thing values. The computation formula will be presented by formula 9 and 10 respectively. The configurable composition with insertion QLT of thing is realized through the aggregation of all the paths. As a result, the computation of the final proposition value corresponds to the aggregation of all of the pattern's formulas after customization. Hence, the aggregation value is represented by the formula 11. As a conclusion, it's important to mention that we have presented a systematic quality of think and certain configurable composition approach that is able to provide comprehensive quality of think information for think even with the existence of complex composition structure such as CN, COR, and XOR. As perspectives, we aim to present more experiment results. Also, we aim to support loop patterns. Thank you for your attention. The floor is yours for any question. Here are some references that conducted our work.